Hi guys, this is Gorax AI, and I basically talk about engineering topics, AI topics. And for today I want to talk about 100x engineers and why I think it is going to be end up being terrible for you if you think that you can save your job by automating yourself, because that's what a lot of people are actually planning to do. What a lot of people are planning to do is that they would want to build out a loop that is going to automate themselves, and then at the end of the day this is not going to be the good for them, not because they will be able to automate themselves, but because they will not be able to automate themselves, and Anthropic is going to automate the thing that they are building before they would do it, and they will be out of the job. So if you want to be employed for next 10 years, and if you want to, let's say, build out a company or think about $1 billion idea for that is going to work out in next 10 years, then that is what you're going to figure out and talk about in this video. So to start with, what I think now some people have started to realize is that their token cost is using a lot. Now they are spending maybe double than what they initially used to, but their productivity gain has actually not really improved. They are not able to earn the double the money just by spending double on the tokens. And the reason behind that most probably is because this is how the economy works. Economy pays you out when you're able to solve the new problems that they themselves can't solve. But now when everybody can solve the same problem, the economy doesn't really pay you well for that. And let's look at this video. So this is Chamath.
Let me tell you something really interesting. I sat down with my CTO today and I said, how are we doing on token spend? And he said the most incredible thing. He said, right now, our token costs are doubling every 45 days.
Okay.
And I was like, ugh. And he said, yeah. And I said, well, what is the downstream productivity? And he said, maybe 5% max.
So 5%, like spending double the amount for just gaining 5% is not really a good strategy, you can say. Because if, let's say, the last year you spent $100,000 and now this year you are spending $200,000, or even some people are going to actually spend 10x more than what they have spent last year, the productivity gain is still the same, the flat line. Or maybe if it is supposed to be, let's say, 5%, and that is what the inflation costs basically. So people are not really able to realize the actual value of AI, and only companies that are able to realize the actual value of AI are the people who are actually building the AI, the Anthropic, OpenAI, SpaceX, XAI. These are the people who have gained the most out of this AI thing that is going on. And some people think it is a bubble, though I don't think that it is a bubble. But what's going to happen is it is going to pop up the AI bubble that people themselves are hallucinating right now. These companies, XAI or maybe Anthropic or maybe OpenAI, they are going to be there for a long term. But people who have made themselves dependent too much on these platforms, they are going to pop, and they're going to realize that the token that they are spending and the amount of time they are spending on learning how to do loops or how to build out the goals to do everything hasn't really worked out, and they will not be able to actually come back as well, because people have taken the stance of not even reading the code, but they have stopped reading architecture. They have stopped actually figuring out how to solve the big problems. Let's think. Why would economy pay you if you are solving the problem that everybody else can solve? Yes, okay, even today the goals work, let's say, or even let's say today the loops work, let's say, right? Let's say with the loops you are able to build out a product. The same product somebody else is also able to build out through their $200 subscription. Then why would somebody pay you $1,000 for that? So the same thing is what the companies also need to ask. If they are able to, let's say, automate all of the guys, the 10 engineers that they have in the team, right? Just by automating the job over to some cloud code or over to some OpenAI, why would, let's say, the XYZ company that is in the Silicon Valley, they will also be able to solve the same problem? Then why would investors pay you $1 million for solving that specific problem? So what's going to happen is that these people, I think some of them have stopped reading code. I mean, I also stopped reading code at one point, but now I'm actually back at reading code, looking at the architecture and then figuring out how to solve the tough problems. So I think these people are going to realize the bubble the most. And this is the second video. This is Mark Anderson. So by the way, Chamath, he's actually solving the same problem through 8090. He's going to different companies such as I think some of the insurance companies, the big guys who had a lot of code written in COBOL, and they had like millions and millions of lines of code that they themselves were not able to understand, and they were not able to refactor, and just because of that they were not able to innovate themselves, right? Now what he has done is he has built out the software factory through which he's able to understand that millions of lines of code that is there, and he's able to refactor them into some new language. And these insurance companies are not able to charge, let's say, their customers in a better way. Now they don't have to be stuck in the old environment, and same thing is there with, I think, a lot of infrastructure as well. So what I think Chamath is planning on doing is Chamath is planning on actually tracking down on these specific things that can be solved today with AI, not by innovating new things, because he knows that AI themselves can't innovate unless somebody make it innovate. But he knows that these platforms such as Cloud Code or maybe OpenAI, if you feed it just enough business information, they're able to refactor the old product that these insurance companies needed to. So that's from where he started. He started from the problem that needed a push start, you can say, that a lot of people are not paying the focus on, and he has raised $100 million from that. So that is what you get when you actually pay the attention on how to use tokens wisely. And he's able to sell the same narrative to insurance companies as well. So the same thing is now the Mark Anderson. So he's in this Silicon Valley from a long time, right? He's the initial investors into Facebook and then Twitter. So he knows how the industry works, and let's listen to what he has to say about OpenAI.
I think there's basically like two ways to really differentiate an edge, like general, right? There's sort of, there's kind of go deep or go broad. Go deep has kind of become a more and more specialized expert over time. And look, there are domains in which that like really matters. Biotech and working on AI foundation models, like that stuff really matters. The deeper you are, the better. I think for most.
So basically what he's trying to say is that either you have to go deeper or you have to go broader, right? Now, the deeper are the companies that are, let's say, able to solve some specific problem that OpenAI themselves are not able to solve, or is, let's say, too far away from them. For example, 11labs, right? For example, Kling AI. Kling AI is able to solve the video problem. 11labs is able to solve the voice problem, specifically when somebody has to deploy the agents in the market, right? In the same way, today you can also solve the very specific problem by going deeper into one thing. For example, Chamath has figured out that you can use AI agents to refactor old code, right? So now he's going to go deeper on this refactoring of the code. He's going to go to a lot of insurance companies, maybe governments as well, maybe infrastructure companies as well. And the way he's doing that is by first of all, making AI agents read the 100,000 lines of code. It is actually in millions of lines of code, and it is global. Today, these insurance companies can't really hire engineers to even, read those millions of lines of COBOL, because there are no more engineers who probably understand COBOL. There are very few, right? So he's able to use AI agents to read those millions of lines of code of COBOL, and then he's able to plan that into some English lines. Basically, English lines, I meant to say that he's able to translate 17 million lines of code into 300,000 rules that are readable. Now, human is going to go and read those rules, and he's going to talk to the business people who are going to maybe tell them that these rules are important, these rules are expired, these rules need to be updated, and then they're going to put that into new software, and they will be able to test it as well, because those 300,000 lines of rules, they're able to test that with the old software. They will be able to test that with the new software, and that is how he's going to basically port the software from the old world to new world, and he's going to solve the same problem for other companies as well. So either you have to go deep or you have to go broad, right? Like what Mark Anderson he's trying to say is that if you are able to go deeper, right, on some specific problem, maybe you are able to solve something that people are really distracted right now for. Like, nobody thinks about insurance product, but the guy who knows about money, he thought about it, right? Nobody's thinking about the other domains right now. Nobody's thinking about how to solve the problems through AI using in agriculture, or maybe in hardware products, right? Or maybe some other domains that the AI haven't tapped on yet. So either you have to go and then maybe read some of the physics books and then go into hardware. Now, why would I say that? Why would I say that you need to go and then try to figure out how to look at these different domains? Because the reason behind that is because if you yourself are going to use AI to apply it to now hardware hasn't 10x their productivity yet, right? The same thing would also exist in hardware. Maybe there are some of these robots that are very manual right now, that if they just get AI, if they are just able to smart enough to know that there are 3 different products in front of you, you can maybe pick up the ball through the hand, right? I think that is from where a lot of hardware companies are coming in. So there is this one company which I think hardware hand, right? And it's almost like realistic as well, right? So not here, right? So if you look at this hand, right, if you look at how crazily it moves, you can literally see that this is almost like a human right now. But I think people are going to do is, especially people like Elon Musk, he's going to deploy AI not in software domain, but also in other domains, for example, in hardware, right? And that is where he's going to maybe build out the really good factories that are going to maybe make a very good hardware products. For example, he's very invested in Tesla. He's going to be invested in making hardware for making the GPU chips, and then he's going to use AI to also make some really nice robots, right? Let's say, right? And those robots will be able to deploy in some of the factories to automate some of the workers, which will be specialized in nature. They're not going to be like, let's say, the general robots. They will be specialized robots where they have the general capability. For example, they will be able to move the hand, they will be able to, let's say, talk, walk, etc, 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 but they will need to be able to train to work in those factories, and they will be able to work on those factories to, let's say, solve some specific problems, right? So what Mark Andreessen is trying to say is that yes, the AI has the improvement, but in the AI is going to, let's say, be implemented across either deeply or widely, right? Now I don't understand hardware. I don't, right? And I think people who are probably into software engineering, they haven't really tapped into some of the science or biological products or etc, 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 right? It is hard. And that is where I'm actually trying to get back to. Now today, if you say that you are able to automate and build anything and everything using AI, and you are able to, let's say, automate a lot of stuff using loop engineering, then why can't you solve the problems in biology? Why can't you solve the problems in hardware? Why can't you today go and try to build out GTA 5? Or GTA 6, right? Because you don't have the fundamental knowledge of that domain. You don't have the fundamental knowledge of biology. You don't have the fundamental knowledge of hardware to be able to build out the hardware that can be deployed in these factories. And just because of that, the same argument that you can make to yourself, that only reason behind why you're able to build out the software that you have been building right now is because you have the fundamental knowledge already to how to build that. And you are just replicating that knowledge. Because when you go and then talk to Cloud Code and you say that, okay, you would want to build out this product, right? You would have built it anyways. Because if AI wasn't there with you, you would have built it anyways if you just had, like, let's say, a long enough time, right? But you will not be able to solve the problem that you yourself don't know of. Now, let's say, given enough time, that within 10 months or within 2 years or within 3 years, right? You keep on investing in this loop engineering, you keep on investing in these schools, and then you keep on investing in automating yourself. You are going to end up in the situation where you don't even know what you know. And that is going to lead you to the problem where you yourself will not be able to even do anything. And that is my whole argument. If today you're not able to do anything in biology, in same way, you will not be able to do anything in software engineering if you're going to forget how to read code, if you're going to forget how to, write down the code, if you're going to forget how to write down the architecture, and problems are going to get much tougher. In 2008, the toughest problem was to actually build the WhatsApp, right? Because building the WhatsApp, the problem was not that people couldn't do the messaging. They could, like using facebook.com, they could say send the message, but it used to take a few seconds, I remember. But then WhatsApp came on, and then WhatsApp came along, and then WhatsApp solved the same problem where messages can then be delivered on the internet just in few milliseconds, right? And if you look at the backend infrastructure of WhatsApp, it is not simple. It is chaotic. It is like a lot of distributed systems that are going on, where a lot of servers are themselves working along with each other to be able to, let's say, send the one message from one system to another, right? Now what I'm trying to say is that was the problem that people solved in 2008. Even if you go today and then ask Cloud Code to be able to build a WhatsApp software, it will do a very terrible job. It will end up making the context where it is able to send the message over some TCP protocol, but it will not be able to think of distributed systems unless you tell it about distributed systems. And you will tell it about distributed systems if you yourself have the knowledge of distributed systems. And even if, let's say, you are able to tell it about distributed systems, how would you tell it about handling the failure of nodes? Because it can try to solve that just using the try clause, right? But in order for you to handle the failure of nodes, you need to be able to, let's say, monitor these nodes, right? You need to monitor this health, and then whenever the message is in the backend system going from device A to device B, you have to cache it as well, so that if the system crashes, the message doesn't get lost. Now, if you yourself have all the knowledge of how to build the WhatsApp management system, you can actually build it using Cloud Code. But if you yourself don't have the knowledge, you will be completely dependent on Cloud Code to be able to make it for you. And Cloud Code is going to do a very terrible job. Either Cloud Code will be able to solve the problem using the same thing that other people are solving, so nobody will pay you high enough to actually solve that problem, or you yourself have the knowledge of the architecture where you will be able to solve the same problem. Now what's going to happen is that was 2008, and this is 2026, and people have deployed the AI systems, and people have not deployed the AI systems that talk like you, that can talk like you, that can act like you, that can have the face like you, that can basically do anything and everything that you do, right? But if you yourself are not getting deep into this AI thing, if you yourself are not understanding how the AI model themselves work, if you haven't even heard of attention is all you need people, you have lost yourself. This new Gen Z generation, or this whatever you call them, right? They're going to run over you, because at the end of the day, they're going to know about the fundamentals of these LLMs, maybe through colleges, maybe just because they're curious enough, right? They're going to learn about this transformer architecture. They're going to maybe learn how to optimize these models to solve the very specialized problems in their own domain that they have thought of or read about, and they're going to run over you basically, because they will have a very different perspective, and you will just be stuck in this loop where you are just automating yourself. So at the end of the day, what I'm trying to tell you is that this is what people are doing these days, by the way. People are not able to understand how Facebook was built with zero tools and then no AWS or Vercel, right? And that is what people are forgetting too. Like, what innovation have we done in last 2 years? You should try to ask yourself this very same question. What innovation have people done in last 2 years, especially the white coders? Yes, maybe they have developed some of the small applications that are deployed on the internet, but nothing more than that. There is no innovation going on right now by white coders. I would like to say that. Yes, there is some innovation going on by people who are getting deep into AI, who are getting deep into, let's say, RSI, the recursive self-improvement part, who are getting deep into how to build voice agents, who are getting deep into how to build AI characters that can talk really well, right? But in order for you to do anything and everything in that space, you can't just use cloud code for that. You have to go and then yourself learn how to be the AI engineer, or you yourself have to learn and have the specific knowledge that you can then build it using AI. So that is where I think the AI comes in, right? What's going to happen is that in future, there are going to be more and more people who will be needed in the market, let's say, right? Who the people will not be able to hire. So that is where I think Jeff Bezos came in, right? Jeff Bezos basically says that in future, there are going to be more demand of AI engineers and they will not be able to fulfill. And the reason behind that is because people are going to actually not read the fundamentals of AI itself. People are going to read the fundamentals of software itself, and they're going to try to automate and then think that the AI can do the job for them. But whenever the AI will do the job for them, they have just lost the value in the market. So what I would recommend you is that you actually go deep on AI, that you don't stop reading the code, that you try to solve the problem that you can, and then whenever, let's say, you are trying to build out something, try to read it through tokens window, right? Because right now, let's say you are spending, maybe you have cloud code subscription right now, right? Because what people are not thinking is that this cloud code subscription, they are going away sometime soon. Maybe not today, maybe not tomorrow, but they're definitely going away, maybe in 6 months, right? So for $200 of subscription of OpenAI, he's able to use $8,000, approximately $8,000 of usage, right? So there's clearly the space where OpenAI is subsidizing these tokens, and same thing is also happening for Cloud Code. Cloud Code is also subsidizing the tokens, a lot of tokens that are in the subscription window, because right now they are in the innovation phase. They themselves are trying to improve the product where they can basically automate you, right? And if they're able to automate you, but company are going to do is companies will not, yeah, company will still need to hire you, but they will not be able to, they won't need to pay you enough to retain you, right? And that is what is going to get you out of the market within the next 10 years if this thing happens. So what you should do is you should be able to think that, okay, just do one experiment, right? Try to not use Cloud Code, try to not use Codex, just go to Open Router, just buy $100 worth of tokens, and then try to build out the product using that. Now, whenever you will try to build out the product using the real economy, not the fake economy of Cloud Code and Codex. By the way, I think Cloud Code and Codex have a big hallucination problem that we can talk about in some other video. If you just go and then try to deploy the Hermes agent, right? And then buy $100 worth of Open Router tokens and try to solve the problem. And every time you are sending a message, you should know that you are actually spending the money. And then First of all, what you will try to do is you will try to define the architecture. Now, because now you know that you can't just run it in a loop, you can't just ask it to do the goal of build out XYZ product, because now you know that, okay, at the end of the day, it is spending real money, at the end of the day, it is spending tokens, the real economy, right? Now you will try to think about the problem in a better way. But rather than trying to build out 100 different things, you will try to just think of 2 things that you can build that are needed in the market. And that is what startups were always about. That is what software engineering is all about. Trying to figure out what you can do today, trying to figure out top 3 things to do, and then trying to figure out 99% of a garbage that you don't really need to build, but you can just ignore. Basically, that comes under product management stuff, right? And the software engineering is about how to deploy it in the market, that you know clearly that you will not be able to, let's say, get the million customers on the first go, right? Or you would want to deploy to enterprise where they can handle million customers. Now, in both cases, you need to know how to scale it well, right? So you can't wait for 1 year to deploy something. You have to, let's say, figure out how to deploy it in iterations. And then while you are deploying it in iterations, you have to figure out if your application breaks, how to recover it, and then how to, let's say, build out on the top of it so that you are able to serve million users, which require you to actually think and then learn about distributed systems, and then which requires you to actually handle errors in a graceful way, right? You will have to think about observability. You will have to think about everything and anything that comes under software engineering. And that is how I think you can stay employed for next 10 years. If you're able to use $100 worth of tokens to build out a software today, that is what you will have available for next 10 years, because the subscription models are going away. And when they go away, a lot of people who are dependent on the subscription model, they are going to, let's say, get out of this economy. But I'm afraid that's going to happen is that a lot of people are going to forget what the software engineering is at that point, and they're going to ask code or Codex to solve the problem for them, and they're going to spend a lot of tokens, and it's not going to be worth it, because today these people, right, the tokens they are spending, and most probably they also have the subscription model running right now, the token cost is doubling when the improvement of productivity is just 5%. Imagine what happens when, let's say, the subscription model goes away. It's going to get much worse, right? So what I will try to tell you is that, try to solve the problems, try to think about, what people are thinking is that they will be able to, let's say, what's happening is that what people are thinking is that everyone is basically bragging right now about a million token context window, right? But there is something that they right now don't tell you. So with 256k tokens, GPT 5.5 scores 80%, right? But then it drops to 36% whenever it is pushed to 1 million tokens, right? Or million context window. So basically GPT 5.5 itself performs nicely whenever it is in the lower context window, and it performs much worse when it gets pushed to million tokens, right? And maybe this is a problem that can be solved, right? Let's say this problem can be solved. Let's say OpenAI tomorrow is going to release the GPT-6 model, and they're going to release 10 million tokens context window, and they're going to solve the problem for you. But then they have solved the problem not for you, they have solved the problem for the company where you are employed right now. So you should know about this clear distinction. In order for you to be still employed, you need to think about how to be creative, because they would pay you a higher amount if you are solving the problem that the Cloud Code and GPT can solve. And for you to do that, you have to learn critical infrastructure. I would just end this video at one point, right? The 100x engineers are not those who are able to write down 100x lines of code. 100x engineers are not those who are able to write down 100x faster. They are those who can handle the 100x massive system that just people are afraid to handle. They are people who are able to handle the payment system where billions of dollars are going from here to there, and they're able to look at the problem and then solve it in 30 minutes. They are those people who are able to solve and then look at the WhatsApp management system where maybe millions of users are talking to each other, and then he's the engineer who can go and then try to deploy the system or recover the system rather than losing the messages. So 100x engineer is not the guy who can build out a 100x bigger system. 100x engineer is not the guy who can build out 100x bigger amount of a code or the project that is just a slop. 100x engineer is the guy who is able to actually manage that as well and then build that production ready, and that last 5% is something that is going to get you and keep you employed. And then in order for you to be employed, you have to think deeper, and in order for you to be employed, you have to learn how to code. So maybe it sounds contrary in this period, but that's what's going to happen, I think. And that is how you, I think, can stay employed for next 10 years. Or for, if you are lucky enough, you're able to find out a problem that you can solve today that a lot of companies are not paying enough attention to. And then you can go wider, you can look at your own community, you can see which problem that nobody's tapping into, you can solve that. But in order for you to come up with that problem, you have to be creative enough. You can't ask cloud code to figure out the problem to solve and then expect you to get paid for that. The money doesn't work that way. The money works where economy, where a lot of people are ready to owe you, let's say, something just because they themselves don't know how to solve the problem. If they themselves know how to solve the problem, they will owe you nothing. And if they don't owe you anything, you are not going to get paid. So try to do something that a lot of people are not doing. Don't get into this zone of just learning and doing everything that a lot of other people are doing. Yes, of course, in 2020 as well, you needed to know how to use REST APIs. But then you wouldn't get paid $100 million just because you know how to use REST APIs. So today, yes, you will get paid if you know how to use prompt engineering, but you're not going to get paid a lot of money, or if you're not going to get paid as a senior staff software engineer or get hired at a very good company if you just know how to use prompts. So the prompts is the same thing as using REST API in 2020 or 2008 for the matter of the fact. So don't just be the REST API engineer, try to be the distributed systems engineer in this economy, and you can then get paid well. So yeah, so do follow me on YouTube. We're going to make more of these videos, and thanks for watching if you're watching till this time. And I'm also planning on launching some of the courses for specifically harness engineering. And what I would recommend is that you follow me on Twitter, and then I would be posting over there all of the updates, or subscribe me. You will come to know about the videos through the notification window that way. So thank you. Thanks a lot.